Hello and welcome to CodeSlicing. In this exciting episode, we're going to round out the discussion on activity indicators by blowing your minds. A good way to finish, I think you'll agree. First of all, we're going to take what we did in the last episode and extract it out into a modifier that will allow you to take any design and turn it into an activity indicator in one line of code. And if you haven't seen that episode but want to be brought up to speed, that's probably a good place to do it. Once we've extracted our modifier, we're going to apply it to the approach of using masks that we explored in the first couple of episodes on activity indicators and end up with something that works for bespoke circular designs that lack rotational symmetry. As you can see, we're starting out where we left off in the last episode, and all this stuff here is what we want to extract into a custom modifier. We can't really use automated tools for this since we're going to be doing quite a bit of cherry picking, but I can copy all this and create a custom modifier here. We'll call it Activity Indicator Modifier. And we're going to dump everything we've got in our clipboard into the body like that. There's loads of cleaning up to do, but yes, I'm including the Z stack and the for each here on purpose, since the view modifier is going to take care of all of that rather than the call site. As you can see, my template for a view modifier includes an extension on view, but we'll get to that in just a minute. There are quite a lot of parameters we need to take care of first, so forgive me, but I'm going to whiz through them since we don't have time to hang about. We're going to be passing in the offset since the call site is going to be responsible for calculating that. I've also included a couple of extra properties based on the ones we'll be passing in for iterating through the segments. We're going to be setting all that up in the initializer, the majority of which I'll stick in now. Now, in order to calculate the rotation per segment and the delay per segment, we're going to need to know what fraction each segment takes up, which is essentially the inverse of the number of segments, like this. Let fraction per segment be equal to 1 over the number of segments as a double. And now it's very simple to first calculate the rotation per segment, and we're going to use the convenient cycles extension on angle because that only needs to know the fractional rotation. And the delay per segment is simply going to be the duration multiplied by the fraction per segment. Now we've got all our properties set up, we just need to make a few changes to the body in order to make it behave the way we want. So I'm going to take the content and replace the capsule with that. So I'm going to remove the capsule, the fill color, and the frame. I'm going to get rid of our geometry reader because we don't need it now. I can get rid of the clear color. I'm going to replace the offset with the offset that's getting passed in, and the fade factor with the fade factor that we've got as a property. And lastly, because we're setting animating to true, we need an animating state variable for that, which we're going to initialize to false, of course. All right, our view modifier is ready to go. So let's set up that extension on view to allow us to use it to initialize our new view modifier. Let's blaze through the boilerplate. Now we need to clean up our main view in order to use our new view modifier. So we go up to our main view, we can get rid of animating, all of these constants. We don't need the Z stack, the color, the for each, or the delay. All we need is the capsule, fill color, and frame. We can remove the rest of this stuff, and we don't need that, so we just need to re-indent this. And at this point, we need to address the fact that a geometry reader behaves like a greedy Z stack with an alignment of top leading. So we need anything inside that to be greedy. We did that before by putting the clear color at the bottom of a Z stack. But now we've just got our capsule, so all I'm going to do is give it a greedy frame overall. All we need to do now is render it as an activity indicator with our new modifier. Render as activity indicator. We've got 8 segments. The offset is geo, height scaled by 0.35, duration is 1, and the fade factor is 1.4. Now we're in a great position to resume and play. And would you look at that? An activity indicator in one line of code. We can enhance it slightly because we might have segments that have a preferred orientation, and this will rotate them. Let me demonstrate by using an emoji. So instead of all this, we have a text, which is the cool emoji. We'll say the font size is related to the width scaled 0.2. So we've got our emoji and they're being rotated, which looks pretty cool, but say we wanted them all to be facing the same way. let's add another property to our activity indicator modifier. I'm going to call it maintain orientation, which is a Boolean. Then we can add it to our initializer. We'll default it to false and set it here. And then, because I'm going to need it twice now, I'm going to calculate the rotation just inside the for each. Rotation per segment times index. And then I can use a nice conditional modifier here. Rotate if maintain orientation minus the rotation that we just calculated. I'm also going to use it here. Just like that. And then obviously we're going to need it in our extension. So let's just copy that. Put it there and pass it into the initializer. Okay, now we should be able to go up to our main view. And in this case, say maintain orientation is true. And then we can resume. And they're all looking much happier. Now, this is all brilliant, but we can go even further because using this modifier results in an activity indicator that is rotationally symmetrical, right? What if we wanted to have some asymmetry in our design? And would you believe it? Here's an example that demonstrates exactly that. Nothing too fancy going on here, except perhaps this line, which I'm using to control the scale of the circles. I'm taking half the rotation, the cosine of the result, taking the absolute value, and then using it as a CG float. To make things easier for myself, I've got an odd number of segments, so I don't have to bother with the point at which the scale would be 0 exactly halfway round. But the point is that we can't use our new modifier to create something like this. But we can use a mask for this, and we can create that mask using our modifier since the mask itself is going to be symmetrical. Let's define our mask down here. We'll call it circular activity mask. It's going to need the 3 properties that we've come to know and love, so I'll blast through them right now. And our body is actually going to be arcs, right? We're going to create these arc segments that we can repeat using our modifier. So before we can do anything, we need to define that shape. We'll call it segment arc. And PureSwiftUI is going to make this very simple indeed. We just say path move rect.center. Now, in order to draw this arc, I'm going to need to know the arc length. And once I know that, I'm going to draw the arc at the top of the circle, which means I'm going to be going half the arc length to the left of the top to half the arc length to the right. So I'm going to pass in the arc length, which will be controlled by the circular activity mask, and then calculate half the arc length in the initializer. So let's set that up now. We make a private, it's half the arc length, and it's an angle. And then in the initializer, we take in the arc length and say half the arc length is equal to the arc length times 0.5. Now we can draw the actual arc. So once we've moved to the center, I can say path arc. I'm going to give it the center point, which is the center. The radius, which is either half the width or half the height, doesn't matter. The start angle is going to be the top minus half the arc length. And the end angle is going to be the top plus half the arc length. These named constants in PureSwiftUI really do help to make things very clear when you're drawing paths like this. That is our arc done. So now we can go to the body of our circular activity mask and refer to it there. Segment arc. The arc length is going to be equal to, remember the cycles extension on angle, we're going to take the inverse of the number of segments as a double. And that gives us the angle that one segment takes up as a fraction of the entire circle. So now that we've got that in place, let's go up to our main view and we're going to add our circular activity mask as a background. Background, circular activity mask. We're going to pass in the number of segments, the duration, which we'll just set to 1, and the fade factor, which will make 1.4. Now let's resume and see what we've got. And since, as I mentioned in the first episode, when working with masks, I like to make them red in order for them to stand out against our design. So let's go to our segment arc and fill it with red. Fantastic. Now all we need to do is to use our new modifier to render this segment arc as an activity indicator. So we say render as activity indicator, and we're going to use this one where we can pass in the number of segments. The offset in this case is going to be 0 because we're placing that arc explicitly in the frame. We don't need to offset it. All we want this modifier to do is rotate it and animate it. So we set the offset to 0. The duration is going to be the duration, and the fade factor is the fade factor that's being passed in. We don't need the maintain orientation since the default is false. And since we're using a fade factor that's greater than 1, we can see all our arcs there. So I'm confident that we can go up here, say mask, comment out the background, and play. And there you have it. Absolutely wonderful. And if you want to see what the mask looks like, all you need to do is comment out the mask and comment in the background. I wonder if it would look better if we had a fade factor of 0.8. Let's comment out the background, uncomment the mask, and I think that looks really good. And with that, I think you've now got all the tools you need to create any kind of circular activity indicator you like with very little effort using these reusable components. Obviously, the mask could and probably should be extracted out into a modifier, but I'll leave that to you as homework. All the code we've looked at today will be available in the description in both PureSwiftUI and native versions, so take a look if you're interested and want to have a rummage through it and maybe a bit of a play. I hope you enjoyed that. If you did, drop a like on the video, and while you're down there, if you're not subscribed, go ahead and do that too. I mean, if you want to. No pressure, of course, but why wouldn't you want to? I mean, did you see the activity indicators we just made? As always, if you have any questions, comments or suggestions, please leave them below. But in the meantime, thanks for joining me. See you next time.